Welcome to another Highland High School physics lesson. In today's lesson, we will take a short look at the concepts of work and kinetic energy and how they are related. To show you how work and energy are related, we are going to use the energy skate park simulation from PHET, and we're going to take the skater and move him up into outer space so that there will be no influences of any forces on the skater until we apply a force in the form of thrust, which basically means we're going to put a jetpack on the skater. And when we put that jetpack on the skater, we're going to see how that force affects his motion. Now we know in previous chapters that when you apply a force, according to Newton's second law, that the object will accelerate. We're going to look at this in terms of work and energy this time. What we're going to say here is that we're going to be applying a force that will act over a distance, and as that force acts over a distance, that will create work because the definition of work is force times distance. Now, we also learned in a previous lesson that work will cause something's kinetic energy to change, and we will show you how this happens in the simulation too. To do this, we will look over at this energy and position graph, and we will look at the skater's motion at the same time. So what I will do is I'm going to apply a tiny little bit of thrust to the skater. We'll see a jetpack turn on, and the jetpack will indicate that a force is being applied, and the jetpack will be turned off when the force is no longer being applied. So if I put on some thrust, we see, according to the bar graph, that the energy of the skater went up while the thrust was going on, but right now, I've paused the simulation, the skater's energy is not going up and he continues to move at a constant speed. Remember that kinetic energy is the energy of motion, and that speed that he has is used to calculate the kinetic energy. Kinetic energy being calculated as 1/2 mv squared. Now, I'm going to return the skater back to his starting point. Okay, I'm going to play again. Okay, he's not moving yet. So what I will do is I'm going to apply thrust, but this time I'm going to apply the force for a longer distance. That means that when we calculate the work is force times distance. So if I continue to apply the same force as before, but through a longer distance, we should expect that the kinetic energy should increase higher than it was before. If we recall, I believe it was around about 1,000 when I applied it for a short amount of distance. So I'm going to put that thrust on. Okay, I'm going to do it for a significantly longer amount of time, and we see now that the energy went up to 3,000 until the skater reached that constant speed. All right, now we can do this again where we apply the thrust for a lot longer, and we see that the energy goes right off the chart and he begins moving much, much faster. And again, the reason for that is because the work that was done is a product of the force and the distance in which the force was applied. Now, the final thing we will look at here is we are going to just look at the speed of the skater as he moves. So if I apply this thrust, we see as I apply the thrust, we see that this skater's speed increases while I apply the thrust. If I put some more thrust, the speed picks up by even more, and the speed picks up even more. And what we should be able to see here then is that when that work is being performed, the kinetic energy of the skater increases because his speed increases. That leads us to the proof that work is going to cause a change in kinetic energy. Hopefully this simulation helped explain a little bit about the idea of work and its relationship to force and distance, and also work's relationship to kinetic energy. Please make sure you view my other lessons to show you how you will solve problems that involve the work and energy theorem.